So we will continue our discussion on the kinetics of rectilinear translation. So by having our sample problems, okay. So just to have a quick review, so we apply the inertia force, or what we call the reverse effective force, in our problem. So that reverse effective force, just to remind all of you, that is the opposite of the acceleration of the body. Okay, so for us to apply that, so let's have our sample problems here. So first, that an elevator weighing 3,220 pounds starts from rest and acquires an upward velocity of 600 feet per minute in a distance of 20 feet. If the acceleration is constant, what is the tension in the elevator cable? So first things first, let's have our free body diagram, or schematic diagram of free body diagram. Let's say this is the elevator. And so stated in the problem that it has a mass or weighing, no? So our weight of the elevator is 3,220 pounds. Okay, so it starts from rest and have an upward velocity. So aakyat siya pataas, no? We have this velocity that's equal to 600 feet per minute. Ayan. So starting from rest, so ibig sabihin, ito yung kanyang final velocity. So initial velocity niya pala ay 0. Okay. So if aakyat siya pataas, therefore yung acceleration natin pataas. So just like I've said a while ago, that the reverse effective force, or the inertia force, is opposite the direction of the acceleration. So we have this, what we call F sub I, or the reverse effective force, or the inertia force. Okay, opposite. Okay, so what else? We have the, of course, don't forget, we have this tension in the cable. No, ito, yung tension. Of course, yung hihila. This is the unknown in this problem. What is this tension in the cable? Okay. So to solve for this problem, let's resolve this velocity, okay? Stated here, no, that the final velocity is equal to 600 feet per minute. Yan. So resolve muna natin by resolving this to feet per second. Okay? So that is multiplied by 1 minute and then over 60 seconds. So our final velocity in terms of feet per second is 10. No, 10 feet per second. Okay? So that is our final velocity. So first part of our solution is, first part is to consider pure motion. So when we say pure motion, gamit yung ating mga equations, no, using if it is constant acceleration or varying acceleration natin. In this case, mukhang constant naman yung acceleration because it starts from rest, and nakalagay sa ating problem also that the acceleration is constant, as you could see here. Ayan, no, acceleration is constant. So using that, so we have our equation that Vf squared is equal to V0 squared, or V sub O squared initial, plus 2as. So we have this 10 squared is equal to V sub O squared natin 0 plus 2 times A. Ano yung S natin, no, given here, no, na may distance, no, siya, travel distance na 20 feet pataas. Ito, nakalagay na, no, in a distance of 20 feet. So times 20. So we will have an acceleration in feet per second squared. The answer is 2.5 feet per second squared. That is for our acceleration. Now, we will be using that, no, with our equation considering kinetics of motion, no? So for that solution, so second part of our solution is to consider kinetics in motion, or kinetic of motion. So using the kinetics in motion, we will sum the forces along vertical that's equal to 0, assuming that the positive forces are those in upward motion. So let's bring back the free body diagram, or our first part of illustration. So that will become T positive, so minus F sub I minus W is equal to 0. So that is T minus f sub I minus W is equal to 0. So, ito yung unknown sa atin, yung tension. So, that we have T minus f sub I is W multiplied by A over G minus W is equal to 0. So, having said that, so T minus ang weight natin is 3,220. Yan, so we use pounds, no? Pounds times the acceleration. Acceleration computed natin as 2.5 feet per second squared over. So if we use the acceleration na naka feet per second squared, so we use 32.2 feet per second squared na gravitational constant minus the weight na 3,200 pounds is equal to 0. So, resolving that, so our value ng T is equal to 3.470 pounds. So, ito yung ating tension in the cable. Yan. So, this is the tension in the elevator cable. Okay? So, ayan. So, we just use the kinetics in motion ng ating problem. Okay? So, that is for our first problem. So, now, let's move with the second problem. Okay. So, in the second problem, the block shown in the figure reaches a velocity of 40 feet per second in 100 feet, starting from rest. Compute the coefficient of kinetic friction between the block and the ground. Yan. So, pinapahanap sa atin dito sa problem. Our unknown here in the problem is what we call the coefficient of kinetic friction. Yan. Between ano daw? Nung ating ground and nung ating block. So, to analyze this problem, okay, let's resolve this to our free body diagram. So, i-drawing natin siya into a free body diagram illustration yan. So, this is the block, okay? We have the weight, okay? So, downward, that is 161 pounds. Of course, we have the P motion or yung ating force, no, na 60 pounds. Okay, this is the weight. Okay, so if this is moving rightwards, therefore, our inertia force or F sub I will move opposite of this direction. So, F sub I will be in this direction. Okay? Dahil yung ating acceleration is rightward, so leftward siya. And then, we have our, of course, so for, if it is in the ground, okay? So, kung sa ground yan, of course, meron nga siyang friction, and then we have the, kung may friction siya, we have the normal force pataas, and then we have this friction. Yan. Friction on the block F sub R na. Yan. So, this will be our free body diagram. Okay? So, meron tayong pababa na 161 pounds. We have this rightward force na 60 pounds. Okay? So, meron tayong inertia force which is opposite of the motion of this body, and then the normal force and the frictional force. Okay? So, first part of the solution is to consider, again, pure motion. So, ganun ulit. So, first part of the solution is to consider yan, pure motion. Okay, consider natin yung pure motion muna. So, ano nga ba yung pure motion? So, just like I've said, no, so, katulad kanina, so mukhang, kung babasahin natin yung problem, may binigay naman sa atin na velocity. We have this velocity here. Okay, given sa atin yung velocity na 40 feet per second and nag-travel down, no, reaches 40 feet per second in 100 feet. So, mukhang yung distance traveled natin is 100 feet. At yung ating final velocity is 40 feet per second. So, resolving this into equation para malaman natin yung ating acceleration. So, starting from rest, so our initial velocity is 0. So, from there, pwede na natin makompute using the equation of pure motion having constant acceleration. So, that is v sub f squared is equal to v sub o squared plus 2as. So, meron tayo ditong 40 squared is equal to 0 squared plus 2. A unknown, S natin is 100 feet. So our acceleration is 8 feet per second squared. Yan. So that is for our acceleration. So saan ba natin gagamitin to? To compute for the friction using the kinetics of motion. So doon na tayo sa part 2. Our part 2 solution is yan. To consider yan, kinetics in motion or kinetics of motion. Yan. So kung babalikan natin yung ating free body diagram here, yan. So if we're going to analyze this, mukhang we could still use the summation, pwede tayong gumamit ng summation of forces along vertical, or we could use summation of forces along the horizontal. So in this case, since mag-move to horizontally, we're going to analyze or going to use that the summation of forces along horizontal is 0. Okay? So if that's the case, so mukhang lahat na i-consider natin is rightward yung 60, leftward is the friction and the inertia force. Okay? Sige, i-present natin dito. So summation of forces horizontal is equal to 0. So in this case, lahat ng rightward natin, yun ang i-consider natin positive. So in this case, kung rightward, that is the P minus the frictional force, yan, minus the inertia force is equal to 0. So if we're going to resolve this, that is 60, yan, minus the frictional force minus the inertia force, ano yun? That is W multiplied by A over G is equal to 0. So substituting that, so 60 minus frictional force minus W natin, weight natin is 161 times the acceleration, nakapit natin 8 over 32.2 is equal to 0. So we have this frictional force na equals sa 20 pounds. Okay? So that is our frictional force. Now, okay, since we have this value of frictional force, we could use that the summation of forces along vertical naman is equal to 0. Why? Because we need to compute for the normal force. In this case, mukhang kita agad dahil dalawa lang naman ang ating vertical forces, the weight and the normal force. So, in this case, so using, dito na lang, okay, summation of forces along vertical is equal to 0, our n value is equal to the weight, though that is 161 pounds. Okay, so that we have the normal force and the frictional force. So if we have the normal force and the frictional force, we could actually compute for the coefficient of friction. So using the equation that the frictional force is equal to mu sub k times n, or fun, that is, our frictional force is 20 pounds, okay, is equal to mu sub k unknown natin multiplied by our n na 161 pounds. And our frictional force is equal to 0.124. So this is our answer in this problem. So this is our frictional coefficient. Okay, frictional coefficient. So between the ground and the block. Okay, so that is our answer now. Mu sub k, or mu, that is 0.124. Okay, so that is for our second problem. Okay. So now let's move with the fourth problem. Okay, this one. If the pulleys in the figure are weightless and frictionless, find the acceleration of the body. Okay, so that is the question. Ang tinatanong lang sa atin dito, find the acceleration. So A lang ang pinapahanap. Okay, find the acceleration. So ang unknown lang pala dito sa atin ay yung acceleration ng body. Okay, so this is the setup, no? Merong pulley na dalawa, yung isa sa point A, binubuhat niya 200 pounds. Yung isa naman sa point B, 300 pounds, no? So to resolve this, just like your statics of rigid bodies calculation, in this time nga lang, gagamit tayo ng inertia force, or what we call the reverse effective force. I-resolve muna natin to into components. Paano? So paghihiwa-hiwalayin natin yung setup ng ating pulley. So in this case, so sa 200 pounds at point A, so lalabas, no? So meron siya dito tension, okay? Tapos of course, meron siyang weight dito na yan, 200 pounds. Kung ganyan ang setup, that means okay, yung inyong body pala ay aangat. No, bakit aangat? Kasi mukhang sa setup na to, mukhang mas mabigat yung side ata ng ating 300 pounds. So, aangat yan. So, kung aangat, ano ba to? Aangat, pwedeng bumaba, no? Depende kasi mahahati pala. So, i-assume muna natin na bababa yung ating body. So, acceleration natin pababa. So, therefore, our inertial force here ay pataas. Yan, that is in a 200 block. Sa point A, yan, point A or block A. Yan. Now, let's move naman dun sa pulley na part sa may block A. So, yung pulley na part ng block A, so this case, ito yung pulley halimbawa. So, meron tayong tension dito. Of course, the same tension. Ito, yan, same lang. So, ito yung ating tension din dito. So, same. Okay. Tapos, punta tayo dito sa block B. O, block B na. Sa block B na may pulley, so, i-drawing natin. So, ito yung ating pulley sa may block B. So, ito yung kanyang tension pataas, no? Kasi galing dito. Ito, yan. So, ito rin malamang pataas to, tension. So, in that case, so meron ditong block, yan. At point B, yan. Tapos, weigh siya ng 300 pounds. Okay? Weight ng B, yan. Ito sa A, no? Weight sa B is 300 pounds. Okay? Tapos, kung ganyan pala, so, malamang ang ating acceleration dito ay mukhang tataas, no? Tataas, aakyat ba to? Pwede, no? Kasi yung acceleration in-assume natin sa ibababa eh. So, tataas to. So, kung pataas ang ating acceleration, yan. Ang ating reverse effective force dito ay pababa. Yan. So, ayan na. Nakompleto na natin yung mga free body, possible na free body diagram. No, kasi possible kasi pwede tayong magkaroon ng maling assumption depende sa magiging value. Now, kung magkakaroon tayo ng negative value, ibig sabihin mali tayo ng assumption in the first place. Okay, yun lang. No? Parang with your statics, no? Pag nagkamali ka ng sign, mali yung assumption, pero no, from this setup, madali kasi makita no, kung pagdating dito sa 200 pounds, no, alam mong bababa ito kasi mukhang kaya niyang, dun sa style ng pulley, no, bababa, no, bababa ito. Tapos, ang mangyayari ay, pagdating mo sa 300 pounds, akyat naman. Bakit akyat? Kasi dalawa yung humihila, possible na humila. Ayan, so tension niya. Okay? So, parang lumalabas, kung summation lang ng forces kung statics, twice ng tension, force ng tension cable is 300 pounds. Okay, so parang ganito. Ngayon nga lang dahil tinitignan natin na meron na siyang motion, kinetics, so madadagdagan. Okay? So, kung kino-consider natin, assuming that the block A will move upward, block A will move downward pala, ito to. Assuming block A will move downward, ito, yan, downward daw to. Yan, in-assume muna natin, no? Downward, we could say that, okay, from this setup, no, kasi bababa to, tapos aangat, no, yung inyong sa B, no, tama ba? Aangat ba? So, pero dahil, kung titignan natin na twice na kailangan ng tension, o parang mahahati, no, yung force T pag sa 300 pounds, pwede ba nating sabihin na yung acceleration sa A is equal to that acceleration na hinahanap natin at yung acceleration sa B is 1/2 that acceleration sa A sub A or 1/2 sa A ng acceleration. Dahil kung titingnan nyo, kung para sa 200 pounds, isa lang. Pero sa 300, naging dalawa. So, same value lang naman yan ng tension. So, ito ngayon yung assumption natin. Ngayon, pa nagkamali yan, that means mali tayo, or pa nag-negative ito, that means it give us the wrong assumption. Ulit tayo. No? Pero, umpisahan muna natin kung downward yung motion ng A. So, i-consider muna natin, first, yung free body diagram ng block A. Ito. So, drawing ko ulit siya dito. So, considering yung free body diagram ng block A, So, ito yung free body diagram niya. So, ito. So, meron ditong tension. Of course, we have this inertia force na, ano ba to? Sorry, acceleration na pababa siya. So, therefore, our inertia force ay pataas. And then, we have the weight ng ating block A na 200 pounds. Yeah. So, considering ito, no? Considering yung ating free body diagram at block A, yan. So, magsasum tayo ng forces vertical is 0, assuming na pataas natin positive. Okay, so that is the tension, positive. Ano bang pataas dyan? Plus the inertia force, okay? Minus, no, minus pala, minus the weight ng block A is 0. So, unknown sa atin yung tension, hindi natin alam. So, tension plus, ang F sub I is W times A over G. Ano ang weight natin? 200, no? Multiplied by A, yung acceleration natin, over, tandaan natin na yung ating acceleration sa A ay yung ating ina-assume na acceleration, times over G. So, kung gumagamit tayo ng pounds, feet, so this is 32.2 feet per second squared minus 200, yan, pounds, is equal to 0. So, our first equation, kung i-resolve natin to, T is equal to, yan, 200 minus 200 over 32.2 times A. Ito ngayon yung ating equation 1. Yan. First equation natin ito, 200 minus 200 over 32.2 times A. Okay? Yan ang ating first equation. So, kung tapos na tayo dyan, so i-consider naman natin ngayon, lipat tayo. Consider natin ngayon yung free body diagram ng block B. Anong ulit yung itsura ng block B? Ito. Yan. So, consider natin tong free body diagram ng block B. Ito, nasa left side ninyo. Ayan, kung nakikita ninyo. So, kita dyan na mukhang may dalawa tayong tension, meron tayong pababa. So, i-redraw na lang natin sa kabilang side. Ayan. So, consider natin yung free body diagram ng block B. Ayan. So, ito nga ulit yung ating pulley, no? Lalabas siya, no? Ito. So, ito yung ating mga tension forces. Yan. So, inassume nga natin na ito ay yung acceleration pataas. No? Kung acceleration natin ay pataas, A sub B, na 1/2 sabi natin ng A. So, ating inertia force ay pataas. Ay pababa. Pababa pala. Sorry, pababa. Yan. Negative pala. Pabaliktad. Yan. Tapos yung ating pulley na setup ay ito. Yan. Meron tayong dito, yan, weight ng block B na equal sa 300 pounds. Ayan. So ngayon, i-consider naman natin, let's consider, yan, free body diagram at block B. Ayan. So consider free body diagram at block B. So ganun ulit, we will sum forces along vertical is equal to 0, assuming na lahat ng pataas ay positive. So it will give us dalawang T, no? 2T. Yan. Tapos minus F sub I minus weight ng block B is equal to 0. Okay? So lalabas yan. That is 2T minus. So this is, kung 300 pounds yon, that is weight, 300. Ngayon, na acceleration ng A sub B ay 1/2 ng A, 1/2 A. No, ito, ayan, no? Nakalagay. Over, yan, 32.2 minus 300 is equal to 0. Simplifying this, no? T, yan, lalabas to T minus or equal to, yan, 150 plus 75 and over 32.2 A. So this will become our equation number 2. Okay? So, ano nga ulit yung mga nabuo nating equation? Yan. So, for equation number 1, no, using the block A, ang nakuha natin dito ay that is T minus is equal to 200 minus 200 over 32.2A. In our equation 2, yan, equation 2 natin, using block B na, okay, we have this equation that T is equal to 150, yan, plus 75 over 32.2A. Okay. So resolving two equations simultaneously or computing two equations simultaneously, we will have our answer, no, that that T, okay, using both equations, okay. So that is the value of T will become 109.091 pounds. This is the tension in the cable. Now, to compute, no, for A, kasi mukhang two equations, two unknowns ito, A is equal to 14.636 pound per second squared. So, eto na yung answer na pinapahanap sa atin. No? Pinapahanap lang kasi sa atin dito ay yung ating acceleration dun sa ating setup. Okay, so this is the acceleration, okay, of the system. Okay? Ayan. Yan yung answer natin. So, meron tayong dalawang equation na nabuo because of our unknown values, no? May T pa kasi unknown din, hindi natin alam. Okay? So, that is for the third problem. Okay? So, for the fourth problem, ayan. So, ito yung ating fourth problem. This fourth problem, I will give it to you as your somehow review problem. No, you could apply, no, yung concept ng ating kinetics of the body, okay, or kinetics of motion. Okay, so ganito rin. So kung makikita natin dito, the problem states that the coefficient of kinetic friction under block A in the figure is 0.3 and under block B is 0.2. So in this case, no, tutulungan ko na kayo. Unang part, let's write all the given. Ang coefficient daw ng friction sa A is 0.30 while the coefficient of friction sa B ay 0.2. Ang unknown lang sa atin dito ay the acceleration in the system. So pinapahanap ulit sa atin yung acceleration in the system and the tension in each chord. So yung mga tension yan. Ilan bang possible tension yun nandito? Mukhang meron tayong dalawang possible tension, no? Meron tayong tension sub 1. Okay, tension sub 1 which is this is the tension, ano ba to? Between, possible to block B and 300 pounds na block. Tapos meron din tayong tension sub 2 na pinapahanap na ito, tension between yan, block A and B. Oh, yan. So, pinapahanap sa atin itong tatlo, no? One, the acceleration at yung dalawang tension. Okay, so I will leave you this problem. So I will forward this a PowerPoint to your group so that you may answer, no, on your own, okay, as a practice problem. Okay? And that is our discussion on the kinetics of rectilinear translation, which is analysis as a particle.